Let's prove de Moivre's theorem by using principle of mathematical induction. De Moivre's theorem states cos theta plus I sin theta to the power n equal to cos n theta plus I sin n theta. Okay, so let's frame the statement. Let Pn be the statement, cos theta plus I sin theta whole thing to the power n equal to cos n theta plus I sin n theta. Then P1 is the statement cos theta plus I sin theta whole thing to the power 1 equal to cos 1 theta cos 1 into theta plus I sin 1 into theta is theta. Obviously P1 is true. Let us assume Pn is true for some n equal to k. Then we want to prove it that Pn plus 1 is true or Pk plus 1 is true. So let's compute cos theta plus I sin theta whole thing to the power k plus 1. So you want to say Pk plus 1 is true, and that is equal to cos theta plus I sin theta whole thing to the power k into cos theta plus I sin theta. Now, by our induction assumption, this is just equal to cos k theta plus I sin k theta. Did we assume P? Yes. Let us assume Pn is true for some n equal to k. When you write k instead of n, then we have Pk is true. So by that assumption, we can replace this quantity is cos k theta plus I sin k theta whole thing into cos theta plus I sin theta. That goes, that is it. Now these are just multiplication of complex number which we can multiply. Let's apply distributive law. Cos k theta into cos theta. Again, cos k theta into I sin theta, that is equal to I into cos k theta. I into cos k theta, whole thing into sin theta, plus I into sin k theta into cos theta, and then I into I is I square. I into I gives you I square, and I square is minus 1, so minus sin k theta into sin theta. So we have two quantities here, or rather four quantities. This is just a real number. This is also a real number. However, these two are purely imaginary number. So let's separate real number and real number, and also imaginary and imaginary number. Let's write them separately. Cos k theta into cos theta minus sin k theta into sin theta, plus if I take I common, then I have cos k theta into sin theta plus sin k theta into cos theta. Now we can combine this as well. For that, we know the formula. Cos A plus B is cos A cos B minus sin A sin B. Cos A plus B, cos, let this be A, let this be B. So cos A plus B is cos A cos B minus sin A sin B. If we apply that formula, then we have cos k theta plus theta. Similarly, here we have sin A plus B. Let's let this be A. Let this be B. Then we have formula sin A plus B equal to sin A cos B plus cos A sin B. I as it is sin A plus B. This is equal to cos k plus 1 times theta plus I sin k plus 1 times theta. Wow, this is wow. Let's write what we have so far. Cos theta plus I sin theta, whole thing to the power k plus 1, equal to cos k plus 1 theta plus I into sin k plus 1 theta. So, this is exactly what we need to prove for showing that pk plus 1 is true. In other words, therefore Pn is true for n equal to k plus 1. Hence, by principle of mathematical induction, cos theta plus I sin theta, whole thing to the power n equal to cos n theta plus I sin n theta. And your n can be 1, 2, 3, dot, dot, dot. So we have proved that de Moivre's theorem is true for n equal to 1, 2, 3, dot, 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 dot. We can also, by reciprocating, prove that de Moivre's theorem is also true for negative n. That means de Moivre's theorem, of course, for n equal to 0, it is obviously true.